Okay, so last time what we were talking about? We were talking about centrifugal acceleration and centrifugal force. Remember, a car moves around a circle. What was the car centripetal force and centripetal acceleration if the radius is 5 meter and the car, the weight is 100 kg and the initial velocity is 25 meter per second, and we got the centripetal acceleration was 5 meter per second square, and centripetal force is 500 Newton. So now just this is the recap. If you miss it, you can check the previous video. Now we're gonna move on to something new, is kinetic energy and potential energy. So kinetic energy is not new, but let's treat it as a new concept. Kinetic energy is half mv square, right? So what is kinetic energy? Kinetic energy is really closely related with potential energy, which is mg change of height. Okay, so let's see what is that. So say this is a x-axis, right? This is a x-axis, all right? And say there is a force over here, that is z, and z always now toward the down, and which is 9.8 meter per second square. Okay, so let's say we have a rock over here. Okay, there is a rock over here. How far? Maybe 5 meter from the ground. Okay, so 5 meter from the ground we have a rock here. Okay, so what is the potential energy of this rock right here? Potential energy of this rock is just the 100%. And what is the kinetic energy of this rock? Kinetic energy of this rock is 0%. If I bring this rock downstairs here, all right, let's put it here. Now rock is here. What is the potential energy of this rock? This rock, 0%. What is the kinetic energy? Kinetic energy of this rock, 100%. All right. Why? Because the kinetic potential energy is just the change of height. Okay. If here full potential energy, if here no potential energy, is converted into something else, kinetic energy. So energy never destroyed. It just convert from one state to another, from potential to kinetic or kinetic to potential. So keep that in mind, that energy never destroy. Nobody can destroy the energy. Just can convert from potential to kinetic. Right. So let's do first this one. Let's say a cart with a 10 kg cart moving 3 meter per second. Find kinetic energy. All right, we are doing this one. Okay, so kinetic energy is half mv square. So half m is 10 kg and b is simply 3 meter per second square, which is half 10 kg 9 meter square second square, and this is just 5 kg 9 meter square second square. So 45, 5 times 9, 45 kg meter square second square. So kinetic energy is 45 kg, 45 kg meter square second square, or we can call simply just joule. Kinetic energy is 45 joule. Alright, so let's use the next half of the space to do the potential energy. Alright, this one. Let's say an object, a rock. We use the example of rock, so let's say rock. A rock weighs how many meters? 5 meters high. A rock, a 10 kg rock, a 10 kg rock weighs 5 meter high. Okay, 5 meter high. Find potential energy of that rock. So potential energy of that rock is mg delta H. So what is delta H? Delta H is, H2 minus H1. Let's write that. Mg H2 minus H1. Okay? H final, let's say H final, H initial. Okay? So what is M? M is 10 kg. 10 kg. What is Z? Z is negative 9.8 meter per second square. We already said that. And H final is 5 meter. And H initial is 0 meter. Okay, so let's use the calculator. Ten times 9.8 times 5 gives us 490 kg meter square second square. We know what is that? That is, this is minus. We know what is that? That is joule. 490. That's the potential energy if you lift. That's the potential energy if you lift a rock. If you lift a rock from 0 position to 5 meters, that would be the potential energy of that rock.